Hey everyone, my name is Sina. This is my first time in ETH Dubai and also in Dubai. And wow, it's a great city. Except maybe those 2 days when all chaos happened. So yeah, I work at the Ethereum Foundation. I'm working on the Go Ethereum project. And yes, first, thank you so much for having me. And I want to show you how you can build the next Etherscan. Before I get started with the talk, I want to highlight that Dubai loves Etherscan. I love Etherscan. It's a great product. This is no way criticism or anything. But, and there's always a but. 2 months ago, recently, Ethereum had its network upgrade, Cancun. And most people were excited, me as well, about the low layer 2 fees, which is obviously great. But in this hard fork, there was another tiny change, or not so tiny maybe, that connected the execution layer to the beacon layer, to the consensus layer. And in effect, it comes down to adding a reference to the execution layer block pointing to the beacon layer, and it's called the parent beacon root. So I was doing some development, and I wanted to know the parent beacon root of a block. And I open Etherscan as usual, and I'm looking for this field, and it's not there. And in that moment, I was thinking, man, I wish Etherscan was open source. Obviously, I mean, maybe some of you don't know, but Etherscan is a closed source product. I think this is how Dubai would look like if people were using there were many options, open source block explorers, and this is how it looks like when there's only one closed source product that everybody is using. So, you know, God sent us a sign, guys. We need to up our game. And I want to send appreciations here to Block Scout and Etherscan. So there exist open source block explorers out there. And in fact, I saw on the schedule that somebody from Block Scout is presenting today in the afternoon. So I'm excited to listen to that talk. And I'm sure that he can attest to the fact that building a block explorer is hard. And here comes the gist of my talk, which is a new feature we added in Geth that I think will make it easier to build a product like a block explorer. And other data indexing solutions. And I'm going to read this out loud here. So this feature allows you to stream observable blockchain data out of Geth programmatically and in real time. Before I dive into it, I want to talk about my good friend, the JSON RPC API. Maybe you don't know exactly what it is, but maybe you heard this guy complain about it on Twitter, and you were wondering what it is. Well, I'm going to tell you, because the JSON RPC API lets you read data about the blockchain. And this includes your account balances, your contract state, transaction receipts, and whatnot. And it allows you also to write to the blockchain, namely by submitting transactions. And the JSON RPC API is great, despite the complaints. I think, in fact, it's so good that it's used in almost every layer of user interaction. So up from the point that you're using a dApp, sorry. This dApp relies on a Web3 library like Ethers or VM. Web3.js talks via JSON RPC to the wallet. Wallet, in turn, talks via JSON RPC to the provider or the EL client. And so like all the way from the end user to the EL client, you can see the same API is being used. In my opinion, this coupling is a bit too tight. I think we should break up the API and have something special for each of these layers. But anyway, that's a whole other can of worms. I don't want to open that here today. Just want to say that for most people, JSON RPC server is perfect. But then again, block explorers are not your average user. they have different data requirements than the degen flipping NFTs every once in a while. They need efficient solutions, and I think the JSON API is just not going to cut it. So you might ask, okay, what are the problems with it? I think the problems with JSON RPC, the first two problems are JSON and RPC. JSON, well, what I mean by that is you're basically tightly coupled to a serialization scheme. And JSON is great because it gives you wide compatibility all across the ecosystem. But you don't really need that when you're developing a data indexing solution. You can opt in for a more efficient solution. And RPC, I think, in my opinion, is not great at combining different resources and batching requests together. And this is from my experience from 2 years ago. So I was doing some experiments on the performance of the JSON RPC server in Geth. And in particular, I was curious how it performs against the GraphQL API that we also support. And maybe not many people know here that Geth also actually has a GraphQL API. I thought not many people know about it. I thought it's undiscovered. It has great potential, and nobody is using it. I did have a rude awakening, though, because at some point I made a change there. And one day when coincidentally we were together with a team, we were having nice dinner outside, we get an angry email from one of the exchanges that, yes, there was a bug in the GraphQL API, and they almost lost a lot of money because of us. So we had to jump on a call at midnight. So anyway, at this point, I realized people are actually using the GraphQL server, some people, not many. And so yeah, I had this hunch that it performs a lot better. And especially for, let's say, when you're requesting different types of data or long ranges of blocks. And I did some experiments, for example, asking for receipts for all transactions in a series of 25 blocks. And you can see that it just blows JSON RPC out of the water. Around this time, somebody opens a GitHub issue. I think he was a MEV researcher because he was complaining that, requesting a lot of storage slots of a contract over JSON RPC is slow. So I was like, okay, hold on, maybe I can do something about that. I wrote this GraphQL query, and sure enough, it's almost 10 times faster. And then comes Felix, my colleague, and he says, well, you know what, Sina? Our JSON RPC implementation also allows you to batch requests. Why don't you try that? And I tried it, and seems to have almost on-par performance with the GraphQL query I had, which was very disappointing to me. I was upset because I wanted GraphQL to be faster. And I did some digging and found a unoptimized path that my query was triggering in the GraphQL Go library that we were using. So I kind of worked around that. I wrote another query, and it was almost twice as fast. The point of these experiments that I'm showing you is that to get JSON RPC to work for your purpose, you might need to do a lot of tweaking, optimizations for every specific query that you do. And this is, I think, a problem. Something else that I want to mention is that it might not, the data model of the JSON RPC might not always fit your needs as a block explorer. It was built mostly for the normal user who wants to interact with the chain. And here I want to bring the example of Etherscan. Now, Etherscan is one of the open source block explorers that I mentioned. It's built on Aragon. And the creator of it realized that they had to add a bunch of new API methods to get the performance that they want and also the data that they want. For example, they had to add a method to get the details of a block. Now, you might know there exists a method like that. We have ETH get block by number or ETH get block by hash. But they just need slightly different fields, and so they had to add their own method for this purpose. Or to get the creator of a contract, this information is not exposed via the JSON RPC server, so they just had to add a new method for this purpose. And with this, I want to end the rant about JSON RPC and go back to the gist of my talk, which is, again, this feature that allows you to stream observable blockchain data out of Geth programmatically and in real time. Now, this time, let's dive into it. So, first of all, we call it the live tracer. And what it does is it lets you write a plugin in Go. Now, unfortunately, this is a statically linked plugin because the Go ecosystem is not letting us have dynamically loaded plugins at the moment. So basically, you would have to compile Geth together with your plugin. But the good thing about it, and I want to highlight this, is that you will not need to fork Geth. And we will see later on why this is so important. The data model here is push-based versus pull-based. So in JSON RPC, you always have to ask, OK, give me block n, give me block n plus 1, give me the receipt for transaction all the time. And you will have to first, you would have to wait for your node to finish syncing, and then you can ask this data of it. Whereas with the live tracer, you will get all of these events sent out to you, like broadcast to you. It also has a rich data model because it is a Go plugin, so you have basically access to the data structures that we use in the Geth source code. And you can pick and choose the field how you want, process them as you want, and then get them out of the node. Now, how does it look like in practice? This will take a second. So you wrote your plugin, you compile it together with Geth, and then you start a full sync. Your plugin will receive events as soon as Geth starts up. It will receive events like, OK, blockchain just started. Oh, I saw a block. I saw block number 1, and I'm starting to process it. In this block 1, there's no transactions, so it's empty. So I move on to block 2. Now, block 2 has 1 transaction. I'm going to go into it. I'm going to start processing. While processing transaction in block 2, I'm going into one of the calls. It's a EVM call here. And such and such opcode were executed, gas changed, there were logs emitted, and so on. And you will see like one call finishes, the next call starts, next transaction, next block, and so on. And you kind of get the idea. So basically, as Geth is chugging along, it's doing its thing, it will also, in real time, give you all of these events and this information. And all the while, you will also receive these other events that are like for state updates. So basically, anything in the state changes, the balance of an account changes, contract gets updated, you will receive events that of the relevant state updates. So with this rich data model, you can not only display or index, let's say, the list of all the blocks and the relationship to one another, because you will also experience reorgs, or the details of a transaction, but also more minute things like which logs were emitted during this transaction or this particular call and in what order. Or you can also see, these are all screenshots from Etherscan, by the way. You can also see how the state was modified during the lifetime of a transaction. Or if you're one of those brave users that clicks on this little button here and presses on parity trace or git debug trace, and you know about that, and you see a page like this. This kind of data is the bread and butter of the live tracer. Very easy to get this data. Now, live tracer was not developed with a block explorer in mind. We started development together with Streaming Fast because they had this product. It's called Firehose. it's effectively a fork of Geth, and it's adding a lot of hooks to all parts of the source code to kind of extract this data that they needed. And then they kind of store it on a flat file and have indexers index the data and put it to some database. And Firehose powers substreams. And substreams is, if you've used the graph, some of the data for the graph subgraphs comes from substreams. So these guys were maintaining a fork of Geth for a long time, and this was a sensitive fork because it touched a lot of parts of the code. And now they just have a plugin. It's a one file, and they add to Geth, and it powers Firehose. The other use case that we were thinking is tracking the Ether supply. This is again a chart from Etherscan, coincidentally. I'm kind of walking through all of the features that Etherscan has and like showing you one-to-one relationship. It's not so easy to get the total supply of Ether from a EL client. This data is not exposed via the API, and there's nuances to calculating the supply. I'm going to read out the description here from the chart. And it says, the Ether supply growth chart shows a breakdown of daily block reward, on-call inclusion reward, on-call reward, ETH2 staking, and EIP 1559 burn fees to arrive at the total daily Ether supply. So it means when you're computing the Ether supply, you need to piece together a lot of different changes, issuances, and burns to get at it. And you need to do deep processing of the blocks to compute this. And I actually think that the chart from Etherscan might not be accurate because there is more. There's more nuance to computing the supply. And here I'm going to bring two examples. And they involve the sneaky little opcode self-destruct. So when you do a self-destruct, you have to specify a recipient address. It means when the contract is destroyed, where should the funds go? Here, what happens if you specify the contract's address as the recipient of the remaining funds? Well, the Ether is destroyed, it's burnt. This is one way that Ether is burnt that is not kind of included here, and it needs EVM processing of that block to find out how much Ether was burnt here. It's same situation with the second example. It again involves self-destruct. It's a bit different here because here it involves two addresses. Basically, one contract self-destructs, and then a second one sends funds to it prior to the transaction ending. And due to how EVM operates, due to EVM semantics, that Ether is also burnt. So we have this plugin implemented. I hope this can power websites like Ultrasound Money. Ultrasound Money, like Etherscan, is also showing you the total supply of Ether and how it changes over time. And it shows the different parts of basically how much was issued, how much was burned. And I know that these guys, they also have a fork of Geth. They have this PR open on the Geth repo. It's been open since September 2022, so it's been there for a while. And I can tell you something, it's not going to get merged. And I was telling one of the maintainers about the live tracer feature, and what he told me was, if it means I never have to rebase again, I'm sold. Like, maintaining a Geth fork, if you're touching core-sensitive parts, is really tough. It's really hard. When you go through a hard fork, so many things change, and your code is going to break all over the place, and it's a pain. And this is why I think like this plugin approach is so good, because you can just add one file, not touch any other parts of the code, and there you have. So guys, this is all I had for today. I don't know if I have actually time. Oh, it's good because we kind of blew through. We blew through this, so I could take a question or two, I guess.
Check. Do we have any questions in the audience? Raise your hand, please. Anyone? All right. Do you want to have any final thoughts? Oh, sorry. I didn't see you.
This is something that I should have asked before, but you say you have to recompile your own, like you have to link the plugin in, right? But could we not somehow have something that would allow people to just hot load some, like write a default plugin that lets you hot load JSON or JavaScript code to specify what you want to trace, and then turn it off when you no longer need it, basically.
So yes, so we do have a JavaScript engine, but the overhead there is big enough that I think it warrants native code. So, and unfortunately, there's not a great plugin system for Go at the moment. So there is a standard library plugin system, but it doesn't work great. It needs you to have exactly the same dependencies as Get, like use all the same version of the dependencies. And honestly, like it's not reliable enough to use this. So I think using a static linked for purposes like a block explorer is not so hard. You really you will probably just write this code one time and then compile it together with your source, and there it is.
Any follow-up?
How about eBPF? That was an idea by Felix. It's like a virtual machine that they start using in the Linux kernel as well. Maybe that would have better performance.
Something to look into, I guess.
Something to work on.
Maybe we can do the talk after the
like
during the conference.
Weekend project. We do this.
Yeah. All right. Thank you, everyone. Thanks for having me.
All right, everybody. Thank you, Sina.